Let's have a look at this. So, quick review from yesterday. Everybody, real quick, get out your notebooks, and I want you to write down, in terms of f of x, I want you to write down what g of x would look like with all of our transformational parameters, meaning the a, where does the a, b, h, and k go? Just for, not a specific function, but just for f of x. Okay? Okay. Yeah, so g of x equals what? In terms, you're going to rewrite, g of x is going to be a transformation, a compound transformation of f of x. We're going to do all that stuff to it, but put in the parameters a, b, h, and k. A, b, h, and k, just so we don't get distracted. I'll close that sucker out too. All right, so how we doing?
So what are we supposed to put?
So I want you to write, so it's going to look something like, I wonder if I can write on this thing, can I? No, I don't think I can. So it's going to be g of x equals, and then instead of an f of x, you're going to put, like, for example, the a would go out in front, wouldn't it? So you'd have a times, but then you take it from there. If you can write this thing, you are, man, this room is just like either freezing or too hot. If you can write that out, then you can do any of this stuff. If you can write it out and you remember what the A, B, H, and K mean. Just take another 10 seconds and we'll look at this. Where's B, kid? Okay, so did you get this?
I mean,
Okay, that's what we need to get, because that tells us where everything goes in the function. Now, what do they do? What does H and K do again?
The points.
Okay, special point. Good. What does A do?
Dilate.
Dilates. Okay, and so we multiply, the vertical dilation factor is just A. So we're going to multiply, if we want to stretch the function by a factor of 2, then A equals 2. It's real simple, right? The vertical stuff is simple. We know that if A is negative, it's reflected vertically, right? Now, by reflected vertically, remember, that does not mean reflected across the x-axis, unless the special point is on the x-axis. It just means we're going to flip the function vertically, so instead of starting at the vertex and going up, it's going to start at the vertex and open down, for example, right? See what I'm saying? Okay, and then what about B? What about B?
Where it goes.
Okay, so B is, well, what's that mean? What does B do? Horizontal dilation. So it does the same stuff as A, only horizontally, which is a little trickier, I think, to think about. But what makes it even tougher is that the dilation factor is the reciprocal of B, right? So if B is 2, then we're multiplying horizontally by 1/2, which means we're compressing horizontally, right? And if B is negative, we're going to flip the function horizontally, okay? And so then, you know, if we were to apply that to specific functions like we looked at yesterday, then here's a couple examples, right? If f of x is the absolute value of x, then instead of writing f of b times the quantity x minus h, all this stuff right here just goes inside the function. So it goes inside the absolute values, or it goes inside the square root if it's a square root paragraph. Okay? Let's look at, just because I want to make a clear distinction between this stuff and the little piece we're going to add today, let's look at a quick example on Desmos. So what if we've got something like, let's do, let's do something like f of x equals square root of x. Okay, now I'll turn this one off here. So what if I want to, actually let's make that a little different. Let's make it square root of x minus 2 plus 3. Okay, so what if I want to, what if I wanted to take that f of x and I wanted to vertically stretch it by 2? Okay, what would I do?
2 outside
Okay, the 2 is going to go out there, isn't it? In front of the square root. So I could put a 2 right there.
Bingo.
And that's going to do it, isn't it? Okay. What if, in addition to that, I wanted to reflect it, flip it vertically? What would I do?
Negative.
Okay, I'd make that 2 negative. Yeah. Right? And look
Wait,
what
what
it
did you
did. It
call that,
flipped
though?
it. Say it again.
What did you call that?
Flipping it vertically or reflecting it vertically.
Okay.
Okay. Right? So when we flip it or reflect it vertically, all we're doing is around the special point, right? That's where we flipped it, was vertically over that special point, right? Okay? So now, instead of stretching it vertically by a factor of 2 this time, let's stretch it horizontally by a factor of 2.
Less than 1. Has to be less than 1, right? No.
Okay, you're right.
Oh,
So, but where does it go? So this is B, right? Where does B go?
where that? X.
Front of the end.
In front of the x minus h. So I got to put the x minus 2 in parentheses, right? And then in front of that, what do I put?
You wanted to do what?
I want to stretch it by a factor of 2.
1.
1/2. Good, there we go. Okay, so 1/2. So it did it, right? Stretched it horizontally. For example, that point right there got stretched over to there, right? And this point right here, which was a horizontal distance of 4 from the special point,
No, 8.
ends up at 8, right? So it did what it was supposed to do. Good. Okay, now what if I want to flip it horizontally? Okay, I make that whole thing negative. And it flips it horizontally, it reflects it horizontally, right? Okay, good. So we got this. Outstanding. Okay, so next issue then. We're going to look at something different. Okay, so let's do a little experiment here. Let's see what happens if we, I'm going to do this too so we can, oops. Let's do this. Let's see what happens if we take this function and we're going to substitute negative x for x. Okay, what's that going to do? Well, would you agree that we get something like that? Okay, let's just look at this math here. So every place I used to have an x, I'm plugging in a negative x, right? So that means right there, that becomes a negative x. And so we end up with this function right here. But that doesn't look right, does it? That doesn't look like our template. If we go back and look at our template, there's our template, right? Let me grab this and we'll just compare. We'll compare our template to what we've got in this box right here. You see the difference? The b has to be multiplied by the quantity x minus h. Here I've got inside, I've got a negative x minus 3. So this takes us back to something that we reviewed at the start of the year that we'll spend a lot more time on later on, with factoring. I would want to factor out, in order for me to get just an x minus something, I'm going to have to factor out the coefficient of x. Well, what is the coefficient of x there? Negative 1, isn't it? So I'm going to undistribute a negative 1 from both of those two terms. What am I left with if I undistribute a negative 1 from each of those? Well, If I undistribute the negative from the x, I just get an x. If I
X.
undistribute it from the -3, I get a,
-2,
no,
+2.
positive 3. By undistributing, it means we're gonna divide by that, right?
Oh, 1 divided by 3 is 2.
So we're gonna end up with a positive 3. And let's just check our work and see if that works. Did we undistribute correctly? If we did, then when I redistribute that negative to both parts, I would get -x minus 3, which I do. Okay, everybody see that? Now, you're not gonna have to do this every time, but I just wanna show you what this does, what it accomplishes. So then if we do all that stuff, okay, what does this look like then? Well, let's go back to our original function for a second, and you tell me, what are the values of h and k in this? In f of x? H is 3, not -3, right? Because h is what's subtracted from x. And what's k?
1.
Okay, good. So we got 3, 1, right, for h and k. What's a?
2.
2. Good. What's b? Okay, so if there isn't
Oh,
one there,
1/2.
it's, no. What is it? So b would be whatever's in front of the quantity x minus h. So what's being multiplied by x minus 3? 1, yeah. Because a and b are things that are multiplied, if they're invisible, they're 1s, right? Anything that normally would be multiplied if it doesn't show up is an implied 1. What if it's something that's normally added or subtracted and it doesn't show up? What would it be? 0. Okay. So if the h and k didn't show up, they would have values of 0, right? Okay, so then b is what did you say b would be then? Oh, what just happened? What's happened here? There we go. So what's b then? 1, okay. All right, so neither of these can. Okay, so there we go, right there. That tells us everything we need to know to sketch this function. The parent graph is just a square root, and we know the values of all the parameters, right? Okay, what about this one here? What are the values here of h and k and a and b for g of x, after we've substituted -x for all the x's? What's h?
3.
No.
-3.
How come?
Got it last time, so.
Well, yeah, but let's look at, here's the template, right? Here's the template, so h is always the number that's being subtracted from x, right? So then, over here, we saw that what's the number that's being subtracted from x there? Well, 3 is, right? So h was 3. What's the number being subtracted from x there?
1,
No, subtracted from x.
-3.
-3, right? Because we have x plus 3, I would be subtracting a negative to make it a positive, right? This goes back, and let me just remind you where this comes from, because you guys have all thought through this before, this process. When we did horizontal translations, you would have told me that that goes to the left by 3, wouldn't you?
Yeah.
Okay, so that makes sense then, right? H is negative, Okay. right? I hear some things clicking out there. So that's, you can kind of sync those two concepts. So we know h is -3 and k is 1. Okay. What's a? 2, because that's the number out front of the function, right? Oops. Come on. It's the same. There. Let's do that. Okay, what's b?
-1.
-1. Right? How come b is -1?
Because it's a negative.
Because that's the number that's in front of the x minus h, right? Quantity x minus h. Okay, so this gives us all the stuff we need to sketch a graph of g of x, because it's a transformation of a square root parent graph with those parameters. So let's do that stuff. Let's go over to this page and let's do that stuff. So let's sketch a graph of a square root with these parameters. So where does the vertex go?
What?
3, 1.
3, 1. So for f of x, we went over 3 and up 1. So it's right there. And a was 2. So this means we're going to stretch vertically by 2, right?
And over by 1.
And then b is 1. So we're not going to dilate it at all horizontally. So normally we would go over 1 and up 1. Over 1 and up 1. So what are we going to do if we're vertically stretching by 2?
Over 2, up 2.
No.
Over 2, up 1.
No, we got to think about this.
What do
Yeah, so this is pretty important. We got to make sure we get this right.
What?
So you're on the right track, but we got to be very careful with this. If we're stretching vertically, dilating vertically, does that change the horizontal distance of the point from the origin?
No.
No, it's only going to stretch, it's going to move it vertically by stretching or compressing, right? So we're still going to go over 1, but this time, how far up are we going to go? 2, right? So this point is going to get stretched because of this. Because of that, this point is going to get stretched up to there. Normally, what's another starting point for our parent graph? Go over, well, 2 is not real convenient because we're doing a square root. Go over 4 and up 2 normally, right? So where should that one be for this graph? If a is 2, over 4 and up 4 should go up to there, right? So then this is kind of a sketch of our, that's a sketch of this guy, right? Everybody agree? Okay. So how about this one then? Here's what you told me were the parameters for this square root function. So we're going to start at -3, +1. So that's right there. And okay, this time a is 2, so we're stretching horizontally by a factor of 2. But what is b doing if b is -1? It's reflecting horizontally, isn't it? Right? So normally, we would be doing this, right? We would be going over 1 and up 1, right? But because we're stretching by a factor of 2, isn't that putting that one up there? Normally we would go over 4 and up 2, but we're going to go over 4 and up 4. So that's all this stuff. But then if we also include b equals -1, we're going to flip that whole thing horizontally, aren't we? Everybody see that? There's a lot going on with this function, right? This is putting our vertex there, and it's stretching it vertically, which we just grabbed. But then this is going to flip horizontally. So now this point, instead of going up 1 and over, or excuse me, up 2 and over 1, we're going to go up 2 and back 1, right? So that point's going to get reflected over to there. This point's going to get reflected back to there. So what did that accomplish? What did we do to the red graph when we switched all the x's to negative x's, or multiplied all the x's?
Reflected it.
Over what?
The y-axis.
The y-axis. Yeah. Everybody see that? And so that's what this looks like, right? If we all we did was substitute negative x's for x's, a really simple thing to do, and the result was pretty important. We did a reflection, not just a horizontal reflection, a horizontal flip. We actually reflected over the y-axis when we did that. Okay? Well, what do you think is going to happen then maybe when we substitute -y for y? So if f of x equals same function, 2x minus 3 plus 1, you already told me all this stuff, right? So we know the values of, oh man, there we go, just get rid of that. not sure why I did that, but anyway. Can't figure out what I'm doing here. Thought this was bragging about this quite a bit with tonight, but there we go. So that's the stuff we already knew, right? For that first one, what happens when we multiply multiply y by -1? Well, y is the whole thing, right? Y is f of x. So if we're going to multiply y by -1, we have to multiply the whole thing by -1, right? So that means we're going to distribute a -1 through all of f of x. So there's two terms here, so that's going to give me a -2 square root of x minus 3 minus 1. Okay? So then what does that accomplish? What's going to be the value? What's going to be the value of h and k for this new function? What's h?
-3.
No.
3.
3, and k is -1. Okay. What about a? -2, right? Okay, what about b? 1. So b stayed 1, but a turned to -2. So let's sketch that. What's that going to look like? Okay, so we already know what this one looks like. We did that one, right? That one had a vertex over 3, up 1. We stretched by a factor of 2, so instead of going over 1 and up 1, we went over 1 and up 2. Instead of going over 4 and up 2, we went up 4. So that's f of x. Now what about g of x? So this time the vertex is going to be at over 3, down 1. What do you think is going to happen? So a is -2, so we're going to multiply all our vertical distances, our parent vertical distances, by -2. So instead of going over 1 and up 1, we're going to go over 1 and up 1 times -2. We're going to go up -2, which means going down 2. Instead of going over 4 and up 2, we're going to multiply 2 times -2 and get -4. So what's the result there?
It reflects
It reflects over
the x-axis.
the x-axis.
The x-axis.
Yeah, right. So when we multiply the whole thing by -1, it flips over the x-axis, right? So here's our summary, right? Replacing x with -x, same as multiplying each x by -1, reflects the graph over the y-axis, not just flipping it horizontally. It reflects it all the way over the y-axis. Replacing y with -y, same as multiplying the whole function by -1, reflects the graph all the way over the x-axis, not just a vertical flip, right? Okay, so let's look at a couple examples. The assignments are up, and you'll see that this is really pretty simple stuff. All right, so how about, so 2.4, practice 1 and practice 2 are up. Okay, so look at this one. All this is asking you to do here is you're just going to look at these graphs. Everybody see this? I'll make this a little bigger. It's going to go through and look at each of these graphs and tell me what's going on. So the red function is f of x, blue function is g of x. What's the relationship? G of x equals what?
Bottom one.
Bottom one. So if I swap all the x's with negative x's, what did that do? Flipped it which way? Flipped it over the y-axis. Is that what we did?
No.
We flipped it over to the x-axis.
So what'd that do then? So which one would that be? Which choice?
Minus x.
No, it'd be that one, right? I'm multiplying the whole function. I'm multiplying y, which is f of x, by -1. Okay, how about here? That reflects it. Does it reflect it over an axis?
The y.
The
Oh, wait, no.
y-axis, right? So this was the x-axis up here, right? This is the y-axis. How do we flip over the y-axis?
Negative x.
Negative x. So it's going to be that one, right? What's that?
It reflects over the y.
So that's going to be f of, I'm replacing x's with negative x's. How about that one?
Over the y.
Does it? Mm-mm.
No. Oh wait.
What
No,
is it?
reflects over the x.
Katie, what is it? What do you see? It's
X.
neither, because it's not really a reflection over either one, is it?
But, oh yeah.
See what I'm saying?
Okay.
If I reflect over either one of those, they won't line up. Okay, so you get the idea. All right, how about stuff like this?
Shoot.
So what's that one? So I'm supposed to say the blue function is what in this case? F of negative x, because reflected across the y-axis. Okay? Okay, and then the rest of it's really just more of the same. Right, so then in that case you would just, if you're going to write out the function in terms of f of x, what's g of x here? G of x is equal to, if we start with f of x, what do I have to do to get that function? How do I get g of x from f of x?
Oh, shit.
We got to make it all negative. Good, like that. Okay. Okay, so that's that. That assignment's really just kind of a warm-up for this one.
Oh, that's not good.
No, sure it is. So how about stuff like this? So what if I want to reflect this function? Now it's a square root graph. Okay, so I might give you some really strange functions here, but it doesn't matter. It doesn't matter what the function is. If we want to reflect it over the x-axis, what do I do?
F. Or negative f and then the x.
Over the x-axis, we're going to make the whole thing negative. But I'm not going to write it in terms of f this time. I'm starting with, I'm actually using a square root of x, right? So that's, I'm going to transform that function. If I want to go over the x-axis, I just put a negative out front.
Oh, that's
Right.
all.
What if it said instead over the y-axis, what would I do?
Make the x negative.
Yeah, I would just do that, and that would be the answer, right? Okay, last one. What about these down here? I want to get one of each. Okay, yeah, what about this guy here? If this function is translated, we got to do all this stuff in order. So what is this going to look like? So g of x is going to be what? Let's start off with just a plain old square root of x. That's f of x. And everybody, if you're not paying attention to this, close them for just a second and watch this, because this is the one. You got to really get this one, and then I think you're good. So what am I going to do here? I have to do this stuff in order. First, I'm going to translate left by 9. What's that do? Trent, close that up. You got to look at this.
It's going to go right.
So if I want to go left by 9, how do I do that, first of all? So I'm just looking at this part right there. How do I say that?
In parentheses first.
Okay, so I'm going to go plus, and I'm going to do x minus negative 9, which makes it x plus 9. Okay, and you see something coming here. We wouldn't need parentheses yet, but we probably will. Now if I want to horizontally compress by a factor of 1/9, what do I do?
That's going to be the b, right?
That's b, exactly. So what's the value of b going to be if we want to
9.
compress by a factor of 1/9? What's it going to be?
Just 9.
9. And that's got to go in front of the whole x minus h. So here's where Aspen was right. We need parentheses around that. And out in front, we need a 9. So far, so good. Now we want to reflect over the y-axis. How are we going to do that?
Make the x a negative.
Yeah.
Good.
Negative.
So the x becomes a negative. You got this. And then finally, if I want to just slide the whole thing up by 6, what do I do?
Six, the outside.
Outside of everything, I'm just going to add a 6. And that's it, right? But you got to go in that order, or you'd end up with a different answer. Okay, so that was a reflection over the y-axis. Let's do one over the x-axis. Nope, that's y-axis again. Let's get an x-axis. Oh. Oh, what do y-axis what? There we go. So now let's start with this one. So this time we've got an x squared, right? Doesn't matter that it's an x squared. Doesn't matter what the function is, we're just going to do this stuff to it. So how do I translate right by 5?
Go or subtract 5.
Okay, and I'm going to have to put this whole thing in parentheses then, aren't I?
Yeah.
Right? So I've got x, the quantity x minus 5 squared. So we took care of this part, right? We translated right. Now we want to horizontally stretch by a factor of 2. What's that going to
2 in
do?
front.
Okay, but we got to be careful. If I'm horizontally stretching it,
One
it's
half
got to be
front.
inside the function, right?
Yep.
So inside the function, I'm going to have to take this x minus 5, and I'm going to have to multiply inside the function. I got to multiply by what? If I'm stretching by a factor of 2.
2?
1/2, right?
Half, yeah.
Good. So here we've got a 1/2. Now that looks a little inconvenient when we've got parentheses around parentheses. So what maybe should I do to those outer parentheses?
Bracket.
Let's make them a bracket. Yeah, so I'm just going to do this. I'm just going to cut all this stuff for a second, and I'm going to change that to a bracket. Oops. Change it to a bracket and paste it back in there. Does that look better? Okay. So now we're up to here, right? We've horizontally stretched by a factor of 2. Now how do we translate down by 1?
You put -1 on the outside of the brackets.
Okay, so good. So we got to go outside of everything and subtract 1. And then finally, how do I reflect over the x-axis?
Make the f
Half
negative.
If I make the half negative, all that's gonna do is flip it horizontally. I want to reflect the whole thing over the x-axis, right? So if it's going over the x-axis, that's just going to it's going to reflect it vertically all the way over the axis.
So you put a negative on the front side of the bracket.
Okay, if I just do this, all that's going to do is just flip the function vertically about its starting point. I got to do one other thing. You're on the right track, but I got to do one other thing. I'm multiplying -1 times the whole thing. So I put a -1 out in front, but what do I have to do to everything else? What do I have to do to all that stuff if I want to multiply the whole thing by -1? Say it again?
Divide.
No,
More parentheses.
more parentheses. Like that.
Jesus.
See what I'm saying?
That's very cool.
Right? Because when I want to flip around the x-axis, we automatically know that means I got to multiply everything. So I can always just put the whole function in parentheses and put a -1 out front. Okay? So it's kind of a mess, but that's what we get. Okay, they wrote it in terms of the parentheses, but same thing, right? We use brackets, but same idea.
How many questions are on this one?
They're really short, 8 on this one, and I think like 7 on the first one will take you about 2 minutes, I think, to do. Okay, go. You can go.